Hi everybody, welcome to another video in Math 1332, section 8.3, simple interest. So, simple interest is the interest that charged only based on the original amount and not compounding. We'll talk about that in the next section, but here's some terms. The interest is the free charge for the use of money. So for example, if we borrow somebody money, we have to pay we should pay back the original amount and then maybe some interest, maybe some percentage of that. And then the principal is the original amount, and the rate is the rate paid for having money loaned or earned in an investment, and without, if it is not indicated otherwise, it is as a percent, and it is for 1 year. So that is very important that the rate is for 1 year. The time, because of that, by default is also per year. So if it is 9 months, that will be 75% of a year, or 3/4 of a year. And then the future balance is what will be the original amount plus the interest. So the loan for investment plus the interest. Right, so that, of course, the interest is the fee charged for the use of money, either for investment or for a loan. Alright, an account is opened with a deposit of $500 and earn 4% per year in simple interest. That means that after the end of the first year, 4% is added to it. How much interest will be earned after 1 year? Now this is obvious. We have 500 and then 4% of that 400. 500 is the interest. So 4% we convert to decimal 0.04 times 500. So that gives us $20. So the interest is $20. Now, if that much interest is earned in 1 year, how much it will be in 5 years? Well, this is simple interest. If the interest for 1 year 20, for 5 years it will be 20. So it will be 20 times 5. So that is 100. And what about in 10 years? So this is in 5 years. Now in 10 years, for 20 times t, right? 20 a year times t. Now use part 1 and 2 and to find the formula for the simple interest. Well, the simple interest, if it is I, then will be equal to how much the principal was, the original amount, times the rate for 1 year and times t. So the total, like 500 times the rate for 1 year and then times how many years it was. Right, so with that, we have the interest for the simple interest. We have this formula. The interest rate times the principal times time, and then that gives us the interest plus the principal original amount give us the future values. Of course, this formula is very simple. We have P is P and the interest is P times RT. Factor out P, we have 1 plus RT times P. Right, so that's what we have. Now let's look at some application problems. Find the simple interest and the future values for a loan of that much if the rate is 8% per year. So we want the simple interest and the future values. The simple interest and the future values. The principal plus the interest. Right, and so we have the loan of that much. So that is the principal, 3,600. And for 3 years, and the rate 8%. That's 0.08. Right. So the principal times the rate times 3 years. The interest rate for 1 year, 3 years. Right. Multiply all of that together. 3600 times 0.08 times 3. And then it's $864. So the future values is 3600 originally plus the interest. $4,464. Right, straightforward. Next, to meet payroll during a down period, United Ceramics Inc. need to borrow 2,000 4% interest for 3 months. So the principal 2,000 simple interest 4% convert to decimal 0.04 for 3 months. Right. The problem is the T have to be in year because the rate is in year. So usually the rate here is for the whole year. So we have 3 months divided by 12. So that is 25% up a year. So we say 0.25. The unit will be years. And that's what we need. Right? So we have everything. Find the interest. And that is the simple interest. So the principal 2,000, the interest rate 0.04, and the T right, and that gives us $20. Right, more example. Apple Chauffeur Services borrow 600, 9% simple interest for 1.15 years. For the interest, future values, and the monthly payment, we assume that for 1.5 years. That it is here. Right, so let's start with right now what we have. Borrow $600. The simple interest 9% or 0.09, and the time 1 and 1, so that's just 1.5 years. Right, now for the interest. So the 600 principal, 9% interest rate, 1.5 years. Give us 81. So that's the $81, the interest. Next, find the future values. Got the future values after 1.5 years. 600 plus 81. Right. So that means in 1.5 years we have to pay that much. But let's assume that we have monthly payment, meaning that after we borrow the money, each month we have to pay back. So this is 1.5 years. If we convert times 12, 1.5 times 12, that would be 18 months. And that's $681 total divided by 18 months. $37.83. So that is the monthly payment. Right, next. Philips Heaven Beauty Spa is replacing one of its workstations. The interest on the launch circuit, so that we have the interest is this much. The money was borrowed, 5.5% interest, so find the principal. Interesting. So this one, we do have the interest. The rate, 5.5%. And then the interest rate for 2 years. It is for 2 years. And then find the principal. So we did we do not know the principal. So the formula we have is I equal PRT. Of course, we can put all the numbers we have here and then find the missing information. The interest is 93.5. Principal we don't know. The rate we do know, 0.055. T for 2 years. Multiply this, because that's 1.1. Sorry, 0.11. And then if we want to find the principal, divide both sides by 0.11. So we have 850. Right, so that is what we have. Next, R&S Furnace Company invested that much for 10 years and received 9,150 simple interest. So that's the interest. What is the rate? So let's see what do we have here. So we do know the principal, the original amount of an investment. For 10 years. And the interest. And the question asks for what is the rate. And of course this is also simple interest. So I equal PRT. Put everything we know in here. 9,150 for the interest. The principal we do know 15,250. The rate we don't know, and time we know. Right, multiply by 10. So multiply this by 10. 150,250 times R. And divide by that from R. So that. Let's round that to 0.061. And of course, if we change this to decimal, if we change this to percent, 2 places to the right, 6.1%. So that look reasonable. Right, so whatever we do the problem in this pretty much on any problem. Whatever the answer, if it look reasonable, it has to be reasonable. So that one is right. So we have two more applications here. So this is two instances that when we have to read the fine print. Right. So number one, many lending institutions use what is called the banker's rule. The rule treat every month has 30 days, so we have 360 days in a year. Right. That sounds good and all with easy calculation, but is that good for us? I mean, if us, from the consumer perspective, if we are the one to borrow money, is that good for us? Right. Take a look. Find the simple interest for that loan at 6% for 120 days. Use the banker's rule. Right. So it's simple. PRT. All right. So find the simple interest. So we don't know that. We do know the principal, 1800. The loan amount, and the time, 120 days. Now if we want to use the banker's rule, we just divide by that by 360. So we have 0.3333 something. Yeah. Right. So the interest, put everything here. 1800. 0.06 and 0.333 something. Right. Actually, it is even better if we just say this times 0.06, and the time we, like I said, we keep all the decimal places. So we just said 120 days divided by 360. Right. So that gives us $36 interest. Right. So that's good. Now, so how is compared to 365 days a year? That in reality, right? So we still have that. So this time we have 1800. The principal, the rate is still 6%, but this time 120 days over 365 days in the year. Right. Actually, if we use this calculator, I just highlight it, copy and paste, divide 365. So I have 35.5. Right. So the difference, of course, is 49 cents. But from a consumer perspective, if we borrow 1800, 49 cents is not that much, but still the interest is a little more than that of the 6%, right? So that is the fine print. Of course, if we read that and you understand that, that's perfectly fine. Like I said, the difference is only 49 cents compared to the actual loan amount. But in terms of if you borrow a bigger amount, all the fine print are really important. And from the banking institution, that means a lot. Like just a little things like that will add up in the long run and will make be a huge profit for them. But for each consumer, the difference is very small, but still something that we should acknowledge, and something that is disadvantage if we use the 360 days in a year. Right. Another one is called the discount loan. So it sounds good with a discount, right? Now, but actually it's not. So the problem is with the discount loan is that whenever we, for example, if we borrow 400 loan then the rate will be 9% interest. So we take away the interest and only pay you what's left. So for example, how does this work? So let's say we have the 4,000, that is the principal. And the time, 2 years. And the rate, 9%. Now find the discount. Well, the discount is just pretty much the interest. Right, so let's write. Pretty much just the interest. Right, so we have 4,000, the rate, the time, so that's 720. Right, so that's the interest. To say what is the big deal? Well, the discount loan, this is how it works. So we said, so the bank can tell you that. So the interest for 2 years is $720. So why don't we just take the interest for now, and the actual amount the student receive is going to be 4,000 minus 720. So the student only receive $4,000. Subtract that. Right, so the student only received this much, and you say, what is the big deal of this? That's 9% of 4,000, that makes sense. And why don't we have to pay the interest later? Why don't we just pay the interest now? What's the difference? Pay the interest now than pay the interest in 2 years. Well, so now consider these scenarios. So bottom line is, what you actually do here is, we only borrow, we got 3,280. Think about it in different perspective. Now let's say you borrow this much, and in 2 years you have to pay back $4,000. So in this case, let's just write, what if the future value is 4,000 and the principal actually it's only this much, and we know it's for 2 years. Right? So what it means is, we borrow this much, we pay back in 2 years 4,000 with the interest. So in that case, the interest is equal to A is equal to I plus P. So the interest is equal to A minus P. $720, right? They say, of course, that's $720. We have that from the previous problem. What's the big deal here? Well, the big deal here is the $720 is to be paid in 2 years and not paid now, right? If the $720 is paid in 2 years, the principal is this much. So now go back to the formulas. The interest now $720, but the principal, because we only get this much now, so that should be the principal and not 4,000. So that's what makes a difference here. The rate we don't know, the time 2 years. So that amount times 2. So 6560 and divide that on both sides. So with that we have the rate is 1.09 sorry, missed the decimal place there. 1.0976. So that's about 10.1%. Of course, in reality, with the discount loan, it is not 9%, it is 10.1%. So the interest is a lot more than what we should be. So to say, why is that? I'll think about this way. If I ask you, can I borrow you $1 million, and I will pay back $1 million. That's $1 million I borrow in 10 years. Of course, you should take that for now, right? Because $1 million now worth a lot less in 10 years. Meaning that $1 million now worth more than $1 million in the future. So $720 you have to get it now is better than in the future, because in the future that amount is not going to be as much in the future, right? So because of that, whenever we said we borrow 4,000, we should better get 4,000 now, and then in 2 years or whatever amount of time we pay the interest. That should be what the deal we sign up for. We should not pay the interest at the beginning now, because now that interest worth more than in the future. So always better to borrow without the discount loan. That is not a good deal. But of course, if you understand that, and that's what you're willing to do, well, that's good and all. But so that is the only details in the fine print. And with that, we finish section 8.3. As always, thank you for watching, and see you in another video in Math 1332.